Have you ever wondered what makes up everything around us? What is the basic unit of matter? Dalton's atomic theory might have the answers. From the smallest grain of sand to the vast expanse of the universe, everything we see, touch, and experience is made up of matter. But what if we could break down matter into its smallest, most basic unit? Enter Dalton's atomic theory, a groundbreaking perspective that revolutionized our understanding of the physical world. John Dalton, an English scientist, proposed this theory in the early 19th century. His ideas were simple yet profound. He suggested that all matter is composed of tiny, indestructible particles called atoms. These atoms, he said, are what make up the elements, the building blocks of our world. Dalton's atomic theory forms the foundation of modern chemistry and physics. It has helped us unlock the mysteries of the universe and continues to shape our understanding of the world. Ready to dive into the world of atoms? Hold on tight as we break down the complex concepts of Dalton's atomic theory. First things first, Dalton's atomic theory proposes that all matter is composed of atoms. Atoms, in essence, are the tiny, indivisible, and indestructible particles that make up everything around us. Imagine them as the miniature Lego bricks that put together the grand structure of our universe. Now, what makes things interesting is the way these atoms interact. They're not just solitary entities, but social creatures that love to mingle and interact. You see, different atoms can combine to form compounds, much like how different ingredients blend together to create a new dish. For instance, hydrogen and oxygen atoms can combine in a specific way to form water. Each compound they form has properties that are different from the atoms that constitute it. This is the essence of Dalton's atomic theory. So atoms are the building blocks of everything we see and touch, but there's more to it. Dalton didn't just stop at atoms. He went a step further and proposed that all atoms of a given element are identical in mass and properties. This is where the concept of elements really comes into play in Dalton's atomic theory. An element, as proposed by Dalton, is a pure substance that cannot be broken down into simpler substances by any means. Each element is composed of one type of atom, and these atoms are what bestow the element with its unique set of physical and chemical properties. So when we talk about the element gold, for instance, we're talking about a pure substance made up of countless gold atoms. Each of these gold atoms is identical in mass and properties, giving gold its distinctive luster, malleability, and resistance to tarnish. This forms the basis of our modern understanding of elements. But wait, there's one more key point to Dalton's theory. Dalton's atomic theory also states that chemical reactions involve a rearrangement of atoms. But what does this mean? Well, let's simplify. Atoms are the building blocks of all matter, the Lego pieces of the universe, if you will. In any chemical reaction, these atoms just rearrange themselves to form new substances. They're not magically appearing or disappearing. They're not being created or destroyed. They're just playing a cosmic game of musical chairs. This brings us to the concept of conservation of mass. The total mass of the atoms before the reaction equals the total mass of the atoms after the reaction. It's like a perfectly balanced seesaw. No matter how the atoms rearrange themselves, the total mass remains unchanged. That's the last key point of Dalton's atomic theory. Let's summarize what we've learned. So we learned that according to Dalton's atomic theory, all matter is made up of atoms. Atoms of the same element are identical, and they combine in specific ways to form compounds. This fundamental concept has laid the foundation for modern chemistry. We've dived deep into the simplicity and genius of Dalton's atomic theory, from understanding that elements are made up of tiny, indivisible particles called atoms, to the realization that these atoms can combine in fixed ratios to form compounds, creating the diverse world of matter we see around us. Dalton's atomic theory has truly revolutionized our understanding of the microscopic world. Thank you for watching the video. If you found it informative, like this video and share it with your friends. Don't forget to subscribe to our channel Facts Academy 0122 for more such interesting videos. See you in the next one.